Okay. So, first thing, I was hoping to get exams done by today, but they're not done. They'll be done next Tuesday. So you'll get exams back next Tuesday. So that's the first thing. The second thing is, excuse me, um, if you're waiting for a part, I have a bunch of parts here. Um, and if you don't have your part yet, I would recommend getting as much of the final report done as you can without your part so that you don't have to spend a lot of time finishing it once you get it because we're moving on to the next thing. Okay. Um, so do as much of your design report as you can so you don't have much to do once you get your part or your parts. How many people have everything you need and have your design report done or getting there for? Okay. Um, okay. So anybody else, it's kind of it kind of has to go like this. Some things get finished, some things don't. But uh, just get the report as close to done as you can. We'll get the part printed. Um, and then you can just do the video, fill in the last sections, that kind of stuff. Okay. Um, so if your part still needs to be printed, um, please email me an STL file. Okay. And I'll get that done before next week. Okay. Anybody have any questions about that? All right. Well, today we're going to get going on the robot project, the last project. And so I'm going to talk a little bit about programming these uh, microcontrollers. You're going to get to fiddle with the stuff, and I'm going to talk about transistors. And then you'll have time today to just start brainstorming, thinking about stuff too. Okay. Um, so would somebody at each table get one of the boxes on the left? The one in the left pile are for our class. So this Arduino board looks like this. So there's a power port up here, and you can plug that into an adapter, or I think there's also a way to power it with a 9-volt battery. Um, But as long as you're sitting at a desk, you might as well just use the power cord. And then there are, I see here, let me use yours again. On in the rows of pins, there is one over here that says 3.3 volts. One that says 5 volts. A couple that say ground. And then over here, there is one that says ground. And then there's a whole bunch that are numbered. So they go from 0 to 13. And a few of them have, like if you notice, 3, 5, 6, 9, 10, and 11 have little squiggles by them. The ones with the little squiggles by them mean that those are especially fast to switch on and off. So those are the fast pins. Yeah. I'm not seeing it on here. Okay. Let's see. I think they should have it. Let me see. Oh, yours. This is a different thing. Oh, is this? Is there another? Yeah, that's longer shoe. Yeah, I was looking for it for a while on that one. Okay, so if you look at those numbers, it's fine. So and the key with those fast pins is they allow what's called pulse width modulation. We can talk about that more later, but that's just a way to, it's like turning the volume of the pin up and down. The pins don't really, the volume doesn't really turn up and down, but you can have that effect by turning it really fast, on, off, on, off, on, off. And then the fraction of the time that it's on versus off determines kind of like the volume of that pin. Okay, so those, for some of you, that'll end up being useful. For some of you, it won't. Just depending on what your project is. And these numbered pins are programmable. And they can either be input or output. So like, for example, you can imagine a case where you would have one of these pins set up as an input from like an optical sensor. And when that pin receives a signal from an optical sensor, then you turn on another pin that's an output to turn on a motor or something. Okay, So that's kind of the essence of like robotics, is like you're sensing stuff, and based on what you sense, your program tells it what to do with the output pins. Okay. Um, and so the inputs are connected to sensors. The outputs are connected to motors, LEDs, speakers, things like that. The sort of the actions of your robot. So I want to just start out with a little thing. We'll all together do a little exercise to program like a blinking of an LED. Okay. And then once we get that working, I'm going to talk about transistors, and then that's all I'm going to talk about today. And then after that, what I want you to do, maybe right now, this is important. Just everybody needs to be in touch with each other. So exchange text numbers or emails or whatever, so that because over this week, you're going to need to communicate with each other to work on the weekly assignment. Okay. And we're just going to little by little get into this project. So everybody log into your desk computers. Oh, that's log me out and log yourself in, I guess. Otherwise, everything you make will go to my folders. You can send me secret messages that way. There are two main sections. In this programming setup. The first one is setup. And that's where you make your definitions, decide for variables. We'll talk about variables in a little bit of programming later on, but that's where you say, like, I want this to be a decimal number. I want this to be like a counting number or whatever. So this is where you make your definitions and define how your communications are going to happen. And then really the key one for the program is the next section, which is loop. And so what this is going to do is when you run this program, it's going to keep going through step by step. It's going to go through all the things you tell the board to do in loop. And it's going to go through them in order. And when it gets to the bottom of the loop, it's going to go back to the top. And it's just going to keep doing it over and over again. And since this is a computer, it's going to do it really fast. So it's going to feel like it's continuously doing it. So like, for example, a simple motor, like if your robot, all it was supposed to do was not fall into the Grand Canyon, okay? You would have the first loop that had your sensor and says, is the Grand Canyon right in front of my wheels or whatever, And it would check that. And it would get this answer back from the sensor that says, no, it's not, because we're in Minnesota. And then it would go to the next one that would say, if you see the Grand Canyon, put the wheels in reverse. Okay. And so it would just go through and through and through. And maybe a month from now, if this thing kept driving, it would cycle through and it would see the Grand Canyon. And then when it saw it, it would put the wheels in reverse. And that's the way that this is going to operate. So that loop is really like the key to how this program works. So the loop goes through the commands in order. And when it gets to the last command, in loop, it goes back to the beginning of loop. And it just keeps doing this until you take the batteries out or turn it off. Okay. So okay, so that's the basic idea. And inside the loop, you can do calculations, and you can also say, you can look for results from sensors, and you can provide commands to output pins. So let's talk about the pins for a second. For each pin, you're going to set it. So each pin can be either input or output. You tell it which one it's going to be. And you can even toggle between them as your program goes on. Sometimes some sensors actually need that. So we'll set the pin as, as input or output. So input would be sensors. Output would be devices like motors. And before you use the pin, in your program, you need to define whether it's input or output. And so you either say, so you use this command. And by the way, this is all case sensitive. So I'm going to try to be very clear about what's lowercase and what's uppercase, but lowercase pin, and then capital M, and then mode. So this is just like, for example, you wouldn't always use pin 5, but you might say, I want pin 5 to be input. And every command is going to have a semicolon after it. That's just left over from the underlying programming language that this uses. Or, as you might guess, if you want to make something output, you'd say pin mode 9, and in all caps, output, and semicolon. And there are some key commands. Well, let's get into that as we go. So everybody, so we're going to start out in the setup thing, and each section is defined, like the start and end of each section is defined by these curly brackets. I usually, just to make it, I mean, you don't have to do this, but this is just what I'm used to. I usually put them down like this so they're a little easier for me to spot. So anything we put between these two curly brackets here is going to be part of setup, and anything we put in between these two curly brackets is going to be loop, and it's going to just keep looping through those things as the program runs. And anything that follows these 2 slashes like this is a comment. So that's not program code. That's just a note, like a note to yourself, buy milk or whatever. You could put whatever you want in there, you know. So the first thing we're going to put in setup is just instructions about the speed of communication between the computer and the board. And we are going to put, so capital S. So everyone start typing this in. Serial dot all lowercase begin, and we want the number 9600. And then we're going to go we're going to choose one of these pins to blink an LED on and off. Okay. Well, an LED is always output. An LED isn't receiving information. So underneath this, we're going to say pin mode. And you can choose any pin you want, 7, let's say. And we're going to say that is going to stay input throughout this program. No, I said output, didn't I? That's going to stay output. And then we are just going to go, I'm going to cheat here. I don't have the syntax in front of me, but this is actually a really useful thing on here that you'll probably want to use a lot. If you go to File in this program, there are a bunch of examples. So we could go, and it tells you what all these, this might be about what we're doing, blink. So I'm going to look at this blink program. And so we have all this. Okay, so what I want to do is I want to first turn the LED on. And I want this to be pin 7. And I'm going to, high means that we're turning the voltage to, you know, a high, instead of like low means 0 voltage, high means voltage of 5 or whatever you're on. So whatever kind of pin you have. So we're going to first turn it on. Okay. Then we are going to delay. So these are in milliseconds. So I'm going to delay for, you know, we could change it to whatever. If you did 500, it would be half a second. Okay. And then, so what I've done so far is when it starts the loop, the LED is going to turn on and it's going to stay on for half a second. And then I'm going to go digital right, that same pin that we're going to have the LED wired to, and I'm going to make it low. And then I'll delay for another half a second. And that's about it. Okay, we're just gonna, and so what it's gonna do is turn on, stay on half a second, turn off, stay off half a second, go back to the top and just repeat this over and over again. Okay. So that's our program. And I think that should have everything we need. And so I am going to compile this. I think this one first checks it, verify, makes sure that there's no errors. So I'll click that, save. And I'll call it LED 260331 for the date. And down here it says it's done compiling. There were no errors that it detected, so that's a good sign. A lot of times if you have errors in the way that you've written stuff down, it'll catch that stuff. You know, sometimes it'll compile fine, it just isn't going to do what you want it to do, but it will catch a lot of mistakes that you make. And so now we're ready to put this onto our board, but it won't do anything until our board is wired the way we want it. Okay. So now let's think about how to wire this board so that it does what we want when. So right now, if we turned it on, that pin 7 would go to 5 volts, then it would go to 0 volts, then 5 volts, then 0 volts. We just wouldn't see anything because we don't have anything connected to it. So now we're going to do this. We're going to go. So if this is our board, so ground, you can think of this ground pin is like the negative of the battery, and the positive of the battery is going to be pin 7. And we want to go from pin 7 to an LED. So like that. And then we want to use a resistor too. So I'm going to put a 330 ohm resistor in here. Remember, the 330 ohm resistor, if you look up at that code, is going to be orange, orange, brown. And then from the resistor, we're going to go to the ground. And we can do all of this using the breadboard. You know, this is the basic circuit that we want. So in order to use the breadboard, I'm going to go like this. Let me look at that breadboard for a second. Okay, so I'm going to take the, so I'm going to go from pin 7 to the red power rail. And from the red power rail, I'm going to go to one of these rows of the breadboard. And then I'll put the resistor in first this time. It doesn't matter which one's first because they're in series. So there's the resistor. And then I'll connect these two, and then I'll put the LED in here. Remember that the LED only works in one direction, so the long leg has to be the positive. And then we'll go from here to the negative power rail. And then from the negative power rail, we'll go to the ground. Are you by yourself today? Brian, you want to move over here? Just so you can work together. And then once we have this wired up, we're going to load the program onto the board, and hopefully we'll see it go. So I want to talk about transistors also, because this is going to be important for us. So if you have a sensor and that's giving inputs, and then you have something hooked up like this LED and the program is telling it when to go on and off, that's how you make a robot. And that seems like it would be the end of it, except that this board can only deal with up to about 20 milliamps of current. Okay, problem. This is something we have to address. The pins on the board can only take and produce about 20 milliamps. And obviously for a lot of robotic applications, that's not enough, you know. So that's much less current than you will probably need. And so to fix that, we're going to use transistors as a switch, as switches. And the transistor that we're going to use, the one that's in your kit, is called the TIP120 transistor. I don't know what TIP stands for, but it looks like this. I'm going to think of the front side as the side that has a black box. Okay, so if you can find this thing. And when you're looking at it from the front like this, the three leads coming out are called the base, the collector, and the emitter. And it works like this. When you send a small current into the base and out of the emitter, it allows a big current to flow in the collector and out of the emitter. Um, and by big and small, this small current is less than 20 milliamps. So we can provide that with the pins of the board. And the big is up to about 2 amps, which is as much current as you'll most likely need. If you happen to come up with a application where you need more current than that, there are other solutions we can use, but most likely that's plenty. That's a ton of current. So the way it works is that the board is not the gate itself for current, but it's the switch that opens and closes the gate for the current. So our Arduino pin will be connected to the base. And the schematic, if you're doing schematic diagrams, it looks like this. So this is the schematic for this type of transistor. There are 3 or so different types of transistors that all have slightly different schematics, but this is called an NPN transistor. And this signals the base, and this is the collector, and this is the emitter. Okay, so let me show you how to wire this, and I'm not gonna show it like with the breadboard and stuff. I'm just gonna show what connectors go to what. So let's say, for example, we have pin 9 programmed as output to alternate between high and low. And we want to connect this TIP 120 transistor to run a motor when pin 9 is high. Okay, so here's how we're going to do it. So here's our transistor. And And there's our base, collector, emitter. You can remember the order of them because they're in alphabetical order when you're looking from the front. And here is our Arduino. And we have a ground over here. And we have our pin 9 here. So we're going to go from pin 9 to a big resistor, 10,000 ohms is a good resistor for this, for every application. And then from the resistor, we're going to go into the base. Okay, so what we've done is from the programmed pin, we've gone through this big resistor and into the base. And the emitter is going to go to the ground. So now we have this small current that we want flowing into the base and out of the emitter. Okay, so so when this pin goes high, that's going to allow current to flow from here through here. And so now to set up the motor, our power source for the motor isn't going to be the board. It's going to be a separate battery or something. So let's say we have a 12-volt battery. And here's our positive and here's our negative. And here's our motor. You have a couple of different kinds of motors in your kit. So here is the positive terminal of the motor. Here's the negative. So our battery is going to go to the positive of the motor. The negative of the motor is going to go to the collector. And then we want the negative of the battery to be connected, to have the same electric potential as the ground of the board. So I'm connecting the negative of the battery to the ground. Okay, and so now this basically will work. There's one more thing I'm going to add just for motors. But what happens is now when 9 turns on, it allows a small current to flow through here and out here. Okay, and what that does is now the 12-volt battery can send current through the motor, through here, and out here. Okay, and so now we have a much bigger current going through the motor than the board could supply by itself. There's one more thing you have to do and this is only when it's motors. You have to connect a diode going in the opposite direction. And the diode looks like this. It's all black with a little white stripe telling you what direction current can go. Okay. You only need to do this for motors. And the reason for this is motors operate on magnetic fields. And when magnetic fields change, you get a surge of current. And that surge of current that can happen from changing the current through this motor can damage the board, damage the transistor, and stuff like this. So this just allows that current to shunt somewhere safely. Okay. But if you're using this battery to power something other than a motor, you don't need this diode here. Okay. Anybody have any questions about that? I am going to give you a little assignment on transistors, just getting used to wiring them up for applications like this. Question?
Oh. What does the diode do with currents?
Oh, yeah. All a diode does, and like an LED is a type of diode.
Yeah.
All a diode does is allow current with very little resistance in one direction, but not allow current at all in the other direction.
Okay, so it's like a one-way gate.
Exactly.
Okay.
So this just allows current to go freely back this direction instead of going through the transistor. Yeah.
Okay.
That's right. Any other questions? Okay, so what I would like you to do is take the rest of the time to just do some brainstorming, look online, just think a little bit about what robotic project sounds interesting to you. Come talk to me if you'd like to see. I think I showed you like at the beginning of the semester. I'd be happy to show you some of the examples that we had last semester. But it'd be nice to just make some progress towards knowing what you're working on before class ends. And be sure you exchange contact information. And that's it.